Most of us have heard of the recently discovered and predominantly submerged continent known as Zealandia, which is a vast stretch of mostly underwater land that lies to the east of Australia. Zealandia only rises above the water in a few key locations, with New Zealand being the largest landmass that exists within it, followed by New Caledonia and a few other surrounding islands making up the rest. The land that has ended up poking above the surface of the ocean in present day, such as New Zealand or the Chatham Islands, are all basically huge undersea mountains, with the top of them being the parts that are above the surface of the water, with a vast stretch of land that sinks for kilometres beneath the surface of the ocean existing below it. But this hasn't always been the case, and New Zealand was almost completely submerged beneath the waves, and was very close to remaining in a state that would more closely resemble the rest of Zealandia today. What really draws me in when I study New Zealand is the geological relationship it shares with Australia, and the fact that the formation of it is so reminiscent of how the eastern states of Australia formed, and this is for a really good reason. Zealandia and Australia's eastern states were joined together by Gondwana, only both of them were ancient seabeds at this point in time, and were flat plains that were accumulating alluvial deposits from the nearby landmass of Gondwana. Both of them were destined to change that, and eventually would rise above the ocean's surface, driven by powerful tectonic processes triggering the event. The insanely explosive volcanic eruptions, earthquakes, and a renewed subduction zone is where New Zealand differs from Australia, and has differed for around 26 million years. Whereas Australia has stayed relatively tectonically stable, with only barely noticeable to weak earthquakes occurring, with the random larger one rare but possible, and volcanic eruptions occurred mainly as flood basaltic eruptions. There's some crazy tectonic happenings in New Zealand that are occurring in the present day, and this is definitely not your typical subduction zone. There's a reason why New Zealand is among the most volcanically active countries in the world, with the most recent supervolcanic eruption on our planet having occurred on New Zealand's North Island. In this video, we're going to take a look at how New Zealand was incredibly close to forever being lost beneath the waves, and how a reactivation in tectonic processes managed to save it from a watery death, and transformed it into the gorgeous North and South Island that exists today. I also want to briefly cover the volcanic plateau that makes up the North Island, and cover why these eruptions are something to not be taken lightly, and why they are not only unbelievably powerful, but also factor in an additional element, and only add to the danger the subduction event that's occurring presents. If you like this content, and want to see more videos just like this one, consider hitting the subscribe button, and clicking the bell icon to be notified of each time I upload a new video, and consider clicking that like button as it really helps the channel out. Around 26 million years ago, New Zealand was almost completely submerged beneath the sea. But it wasn't always like this, and New Zealand once stood above the water, much like any other landmass on our planet does, and it did so for hundreds of millions of years. So why was it suddenly close to becoming, well, extinct? It has something to do with the breakup of Zealandia from Australia, which it was comfortable neighbours with around 160 million years ago, and had happily been so for a good period of geological time. This relationship came to an end when Gondwana began to stretch and split apart at the many lines of weakness that existed within it. Zealandia and the Indo-Australian tectonic plate began to drift apart from one another during this process. When two tectonic plates drift away from one another in opposite direction, the rock that exists at the boundary between them becomes thinner and weaker as it is stretched and pulled away, which causes hot magma from deep below the earth to take advantage of this massive weakness, and through buoyancy, it began to rise up and intrude the weak, thinly overstretched bedrock, heating the crust in the process and adding new, lighter rocks to it. As more and more material was released through volcanic eruptions, the rifting of tectonic plates became increasingly pronounced. Over time, the new material being released eventually formed a plateau nearly 2 kilometers high. By 100 million years ago, this stretching turned into a proper splitting of one another, and massive landmasses began to move their own separate directions, with India moving west and Antarctica heading south. The volcanic plateau that was formed then began to experience the creation of numerous fault systems within it, due to the weaknesses that were being produced by the now split continents, which, in time, ended up splitting this plateau down the middle, as Australia and Zealandia increasingly drifted from one another, forming what's known as a rift valley. At this point in time, this plateau would have looked exactly like the Great Rift Valley of Africa, which is experiencing this exact same scenario unfolding in the present day. By 80 million years ago, the Rift Valley was invaded by seawater, and as millions of years passed, Zealandia and Australia drifted further and further apart. Australia got the better end of the breakup. It got to keep the western side of the volcanic plateau, which is the present-day Australian Alps. New Zealand, on the other hand, was almost drowned by geological forces completely, as it became increasingly stretched, until it sank away to the east of Australia. For almost 55 million years, Zealandia continued to stretch further. By 30 million years ago, little was left of it, aside from a few tiny islands protruding from the sea. 26 million years ago, it caught a break and experienced a rebirth, when a renewed collision between the Indo-Australian and Pacific tectonic plates occurred, which dramatically began to push the submerged land of New Zealand out of the sea again, as the two plates collided and areas began to experience an uplift. Numerous volcanic events occurred in both the South and North Island, forming the present-day land masses that exist, and helping to add thousands of cubic kilometres worth of land to the area in the form of volcanic eruptions. New Zealand might be one country, but the fact is, it's still a very split one. I don't mean that socio-economically or politically, I mean there's an actual tectonic split occurring down the middle of the landmass that encompasses modern-day New Zealand's North and South Island. But not only that, the South Island and North Island are basically doing their own thing on a tectonic level. For example, off the southwestern coast of the South Island of New Zealand lies a trench. A trench means one side of the tectonic plate is going down beneath the opposite plate. In this case, the Australian plate is going beneath the Pacific plate, down to a depth of about 200 kilometres deep. Along the boundary of that plate occurs many deadly and potentially fatal earthquakes, as subduction continues in present day. The creation of New Zealand's Southern Alps is due to this subduction zone, which is located in central South Island. The movement and creation of these vast and incredibly tall mountains is due to the Alpine Fault, which is taking on the movement that is being generated through the subduction zone and is applying it into a sideways movement combined with a little bit of upward movement. This upward movement is why there is such a distinct boundary between Westland and the high peaks of the Southern Alps. Subduction zones are extremely violent tectonic processes. They are basically the largest rock crusher and forge to exist on our planet. So it comes to no surprise that these events generate many small, medium, and large fault systems, along with the main fault that's generated through this collision. And that's exactly what happened in this case. As we move away from the Alpine Fault, which is the main fault of the plate boundary, and continue on our journey further to the north, the Alpine Fault breaks up into a series of different faults, known as the Marlborough Fault System. The very ironically named Hope Fault is the easternmost fault of the Marlborough Fault System, and like the others was created following the breaking up of the Alpine Fault. The Hope Fault is the most active fault system out of the series that make up the Marlborough Fault System. As we follow the tectonic boundary that exists, we now leave the South Island and enter the North Island, where the subduction zone gets flipped upside down, and the opposite to what is occurring in the South Island is literally occurring here, along with an additional element that adds another component of danger to coincide with the already deadly subduction zone. The North Island is actually on a completely different tectonic plate to the South Island. It's a part of the Indo-Australian tectonic plate, and, you guessed it, the South Island is a part of the Pacific tectonic plate. This means Zealandia is actually split in two tectonically, and New Zealand is smack bang right in the middle of where this split actually occurs. So, on the North Island, the Pacific plate is diving down beneath the Indo-Australian tectonic plate to a depth of around 500 to 600 kilometres deep. The North Island's fault system is a bit more scattered, broken, and divided into numerous faults that exist alongside the main subduction fault. This means earthquakes come in a variety of strengths, from the possibility of really catastrophic ones occurring on the east coast of the North Island, which could possibly generate huge tsunamis, to smaller inland earthquakes of varying degrees of strength. When I said the North Island's fault system is a bit more complicated compared to the south, the reason for this is unsurprisingly because of the torpovolcanic zone. The land where the torpovolcanic zone exists in present day is the same area of land that's being stretched apart by the tectonic activity that's occurring. This stretching of the land is producing a weakness that magma is able to exploit like it did when Zealandia first drifted away from Australia. The massive volcanic eruptions that are being produced created their own fault systems throughout the torpovolcanic zone on the North Island, and this is why earthquakes can vary in their strength and location. Earthquakes are generally smaller on volcanic faults like these, compared to ones generated by subduction zones. So because of this collision between these two tectonic plates, the upwelling of magma is unbelievably active all around the region. 26 million years ago, New Zealand was almost lost to the tides, and the way it was pushed out of the sea once more was through the subduction zone, pushing the top plate up, and through volcanic arcs that formed as a result of the melt produced by the process of subduction, which I'll get into in a future video, as this topic definitely deserves a video of its own. In terms of New Zealand's rebirth, this was the timeline of how it rose out of the sea in a step-by-step process. Firstly, the Pacific Plate was forced under the northern part of New Zealand, producing a belt of volcanoes in Northland, on New Zealand's North Island. Over the next few million years, the volcanic eruptions drifted further south, towards Coromandel, while at roughly the same time, the Waitakaa rose from the seafloor in Auckland, turning into a massive stratovolcano over time. The South Island was a tiny island landscape, free of the severe tectonic conditions that were plaguing the North Island. It was a land largely free of volcanoes, earthquakes, and even mountains. But this wasn't something that was going to last, now that subduction had recommenced. The peaceful conditions on the South Island were first broken by a hotspot plume that had been steadily rising towards the surface for several million years, only to finally break through the Pacific Plate around Dunedin. A string of smaller volcanic eruptions occurred as far inland from Dunedin as Ranfurly. Christchurch was the next area to experience another hotspot that had risen and pierced the Pacific Plate, and around 10 million years ago erupted and formed three massive overlapping shield volcanoes, which is modern-day Banks Peninsula. As time went on, more and more volcanic plumes rose towards the surface, and 6 million years ago, further eruptions that released incredible amounts of material occurred. So much magma was erupted to the surface that it permanently brought the land out of the sea through the many blasts that occurred over millions of years. In the North Island, volcanic activity had been moving south and east as the Pacific Plate began to dip down more steeply under the Indo-Australian tectonic plate. The result of this? The notorious torpovolcanic zone. At this same point in time, Auckland began to erupt again, driven by yet another hotspot under the Australian plate. All of this volcanism, spewing enormous amounts of material, combined with the uplift that occurs during a subduction zone, eventually rose New Zealand out of the sea, and many surrounding islands that exist around it, and is why there is such a strong level of volcanism, earthquakes, and a very real threat of a fatal eruption looming in the North Island at any time. The South, on the other hand, has very real earthquake risks and possible tsunamis that can be generated in a split second. And so, New Zealand was spared from a watery end. But the event that made this a possibility still definitely isn't done shaping and moulding the land through the use of violent tectonic events. Thanks for watching. I hope you enjoyed this video. If you did, leave a like, it really helps the channel out. And if you'd like to see more content just like this, hit that subscribe button and click the bell to be notified of every new upload. Thanks for watching. I'll see you all real soon.